think someone was swearing at me in my chat stream, but I didn't actually stop to take a look. So if that was you swearing at me, I missed it. Come on, Twitch. You say I'm streaming on OBS, why don't you tell me I'm streaming here on Twitch? Ah, there we are. Alright, I'll go tell everybody that I'm streaming, then we'll get started. Streaming game dev. Gonna do physics stuff. Alright, so now that everything's set up and running, we're ready to rock. Erdroy says howdy. Howdy right back. Depending on how my new neighbor feels, you may hear extremely loud music. I noticed that they are home right now and have their music on. I can certainly hear it. I don't know if you can. But in the past, they have been known to turn it up so loud that it makes the floorboards in my apartment shake. So we shall see whether or not that becomes unbearable. I would really like to not interrupt my stream to go and pound on my new neighbor's door and tell them they're being annoying. Alright, so can everybody hear me okay? And yeah, I think everything is running fine. I think I'm going to continue developing this physics system. I think that this is a better option than continuing on the galactic line, because the components that I'd need for this are a subset of the components I'd need for the galactic line. Which means that in theory, developing this first will result in a faster product that leads into my dollhouse in space stuff. If that turns out to be false, then it turns out to be false. Right now we've got some warnings here. So the issue is that we have a number of physics component links which are barfing. And I'm not sure exactly what's up with that. I think it's because A and B stop existing when I save and load. They are not serializable objects. The reason that they're not serializable objects is because these are... No, these should be serializable. There are some objects in this list which aren't, but these should be. Unity serialization is a huge pain in the ass, as you may have guessed. So trying to figure out exactly what's going on and where it's gone awry requires some guessing. So it looks like the system has a problem right now trying to figure out what sort of setup it's in. I think I have to reload the objects before I can do this. So to do that, I can go up here and tell it to reload the object list. No, it didn't like that. And then guess at connections. Oh no, the problem is right here. I deleted one of the rocket engines last time and left it with an empty rocket entry. That's the problem. That's much more easy to deal with. Alright, so that should be all I need. Calculate, and that didn't work. Already graphed. Why are you... There we are. I must have not clicked on it correctly. So this has an interesting issue because the ship didn't catch the left half of the ship, as you can see. That's a little bit odd. So we're going to go ahead and tell it to reload the object list and re-guess at connections. We're going to look down here. You can see there are no connections running this direction. None of these objects are counting as part of the ship. Which is really not what I expected. Why is this happening? Alright, well, let's go take a look and see why that is screwing up. So here we should see a reload components from scene, which does this components equals get components by children. Let's go ahead and put in a debug. Debug.log found plus components.length components. Found 12 components. So that's 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12. So 12 is correct. So it found all the components that it was supposed to find. Is it just not guessing correctly? Are these being properly cleared out? So here you can see there are links here. They're just not being drawn, or maybe they're being drawn on the wrong side of the ship. That's interesting. What happens if we were to delete these guys? Okay, so even with those guys gone, we're still drawing those links over there, which means that for some reason these guys are having their connections drawn over here, which is not something I ever expected to see. What could be causing that? Andra Gizmos, draw a line from link A center to link B center. Physics component link, physics component A. So physics component center, return bounds to, oh, so I'm not I didn't recalculate the bounds, okay. So that means that these guys still think they're in the wrong spot. Oh, okay, so this is going to get a little bit complicated because I'm caching stuff and then I'm copying and pasting, and the copying and pasting is changing the cache. Is there a on transform changed, Unity transform changed, transform.has changed? Yeah. So, a change to a transform can be anything that causes its matrix to be recalculated. Note that this operation, before setting this flag, yeah, so that should be fine. Down here in update, we will go ahead and put in a, actually, if it was an update, it wouldn't be a problem. So we'll put it up here in bounds. If bounds.extents.magnitude equals 0, or transform.hasChanged, transform.hasChanged equals false, and that stuff. So that should do. Let's go ahead and redo this connectivity check. There we are. That's better. Now you can see, I don't know if you can actually see that on Twitch, but there are now lines over here rather than over there. Down here in the mass graph, if we recalculate the mass graph, we get the proper mass graph. See? So this system is all working, except for there's no physics involved yet. The question is, do I want to plug in the physics, or do I want to start working on a steerable object, something that'll let me start to play with the ship as I am developing it, for the sake of having fun? And I think that that's going to be relatively important. I know that the physics is fairly easy from here, since I've done it twice before. So we're going to go ahead and implement a control system. We'll call it a ship control system. And we're going to need to assign that to a component. We could have it, in the long run, it will be its own thing with its own visual. Basically, it'll be like a computer core, or a place where people sit around a bridge. But for now, we're going to just go ahead and co-opt this nose system. So we'll drop that in there and we'll open it up. Now the idea of the ship control system is that while it's on, it will gather all of the player inputs and turn them into some kind of control thingy. So we have a couple of options as to how we want to do that. But the core option here is whether the thing is on or off, and if it's on, we need to collect a lot of stuff. Good news is, whether it's on or off is already programmed right into Unity, so there's no big deal there. The bad news is, we have to try and decide how we are going to be setting up our navigation. We've already done some cool navigation tests in the past, so we're going to be using those exact same navigation systems. This abstracted navigation system is great for medium speed to slow speed maneuvering, We might have to use a different control system for high-speed maneuvering, or maybe just an automated pilot that doesn't care. Either way, what we have right now is a distinct lack of any sort of visuals that we can associate with our piloting. So just to make it easy on ourselves, we're going to go ahead and create some visuals for that. We'll go ahead and stick them in this same file for now. It doesn't really matter. And we'll go ahead and make it plenty big, and then go inside and extrude up like this. And then we will just bring this forward, like, oh, wrong side, this forward, right? Yeah. Like this. There we go. That should be fine. And now we're going to just grab the whole thing and extrude it down or up a small amount. 0.05. Grab Z.1. Excuse me. And now what we're going to do is actually delete the interface and mirror it. And later on we'll come back and change it in a variety of other ways, but for now that should do. We'll call it the pilot ring. Hey, Zaku2100. Yeah, I've got allergies. The sun finally came out in Boston, which means that it's time for spring to begin. After 498 straight days of rain. Alright, so the pilot ring can be imported into our system by simply dragging it in, no biggie. Easiest way to do that is probably to create an empty object and then add in a mesh filter and a mesh renderer. We will not be adding in a collider. And then here we will call this the pilot ring. There you are. There it is. You can see that this isn't on center on the ship as far as you can tell, right? Shouldn't be a big issue. There is some question as to whether this is correctly oriented. I think it should be on this blue. It should be 90 degrees off from what it is right now. Zaku says that he also has allergies. I take a lot of allergy meds, but you know how it is. Sometimes they stop working. All of these other objects are offset in an awkward direction. So what we're going to do is we're going to take all of these objects and move them until our ship is centered around the 00 point. The local 00 point, which happens to also be the global 00 point. There we are. That will do. And then this piloting ring will reflect our overall piloting state. So to do that, we're going to need to specify it here in our code. Public void, public transform. No, that's not how it works. Transform pilot ring. And then we'll assign that before I forget. It's on this guy, isn't it? Pilot ring. That means that this should probably be inside of that. That makes more sense. There we are. The only problem is that that's not the center of the object. That's kind of off to one side. That's fine though. It doesn't really matter. 10cast1 says, so today I started making a game about a potted cactus on an electric skateboard that has to dodge falling balloons for points. That sounds easy to understand, so I think that's a good idea. Zaku says that he tries to keep away from medicine. I don't have any problem with modern medicine. I know that a lot of people really hate it, but I've seen some people that hate it who have done a lot of harm to themselves and their children just because they refuse to accept that modern medicine has any merit, which is not what I recommend. Modern medicine is probably the greatest achievement of mankind. That is there, that is here. Here in update, what we're going to do is we're going to take the raw mouse X and mouse Y elements and use them to move our ring. So right in start, we're going to go ahead and arrange it so that our pilot ring pilot ring dot look at, and then we will give it just transform dot forward. Vector 3 dot forward. Why not? Well, good luck with that approach, Zaku. Didn't go very far for me. Float x equals input.get. I think we need to use get axis raw mouse x. I can't remember whether it's mouse x or mouse x. We will know soon enough. So now we say if x does not equal 0, then we move our pilot ring. So pilot ring dot transform dot rotate around. We're rotating around the vertical axis. So here's the question. When you're rotating around the vertical axis, is it the local vertical axis or the global vertical axis? The difference is that if it's the local vertical axis, then when you are moving up or moving down, you will be moving differently. The rotation will move in a different way. For now, we'll go ahead and just make it the local axis, local to this, local to the pilot ring, like so. If y, and you want to rotate by x. If y does not equal 0, then pilot ring dot transform dot rotate, and then we want to run around our transform dot up. It might be better to do something else, like a global transform dot up, just because we're going to have a lot of randomly arranged elements. People might put in their computers upside down and stuff, and I don't want that to screw anything up. Zaku recommends holing yourself up in a room with no, with a hermetic seal on the door in order to avoid allergies. I prefer to just take meds. But I think my my allergies are worse today because the bus was really screwy, and I ended up having to walk 3 miles to get to work. So, got exposed to all sorts of fun shit. All right, let's take a look. So as you can see, this is rotated incorrectly if we want to arrange the z-axis properly. So what we're going to do is we're going to go over into this element system, grab this thing. We're going to apply, what sort of location, rotation, and scale does it have? None. Okay. So we're just going to rotate this by 90 degrees and then apply that rotation and save. Oh, we have to change this from a Z to a Y mirror. That's fine. And that should bring it down. I just don't know whether that is going to be 90 degrees off. Let's find out. So if we take a look, oh, it's 180 degrees off. Interesting. All right, so let's grab this game camera here and move it so that we can see what the heck we're doing. TenChaos1 says, I've gotten to the point that I've got the balloons falling and the player moving. However, I'm having trouble getting the balloons to spawn in random locations. How did I implement color palettes? Because that's how I want to do it. Zaku2100 says you got pollen or something else. We're in Boston, and they were really stupid about the tree ordinances, and they ended up planting some of these weird trees that grow banana-looking fruit, like dried banana-looking fruit, and they produce a tremendous amount of pollen. So TenChaos1, the way I recommend is through a list of colors. And then you can either randomly sort the list or randomly remove colors from that list until you run out of colors and then reinitialize the list. It's fairly easy to create an array of colors. The only question is, do you have to manually specify all of them, or are you going to generate them? If you manually specify them, it's a bit of work, but that's what I recommend. So to do that, you would write something like public list colors, and then you'd be able to specify those colors over here in the inspector, like this, see? And then you can just click here and specify whatever color you want. Just be aware that the alpha starts at 0, for reasons that are unclear to anybody. So generally speaking, what you want to do is you want to set it to a size of 1, and then set that color to anything with an opaque alpha, and then it'll just duplicate that color for the rest of the list, see? And then you can go through the list and either select random colors or walk through it one by one, or pull a color out and then put it back in later when you run out of colors, however you want to do it, really. But this is the easiest way to specify a list of colors. So we have our ring exactly backwards, so we're just going to rotate it around by 180 and then apply that rotation and save. Well, you see, Zaku, if you were stuffing some Flonase up your nose, that wouldn't have happened. TenChaos1 says he'll get to work doing that tomorrow or maybe later. Sure, take all the time you want. So here you can see that we've got a situation where the system isn't rotating except around one axis. If we highlight this piloting ring here, you can see that this changes the X rotation and that this changes the X rotation. So somehow the two axes that we're rotating on have ended up only being, this should be vector3.right, idiot. Except for it should be transform.right, right? Vector, I don't know, we'll have to think about it a little bit more later on. All right, so here you can see that we've got our piloting system and it works. Our ring can be specified here to pilot anywhere we'd want. But you can see how we have some situations where if we're off to the side like this and we try to bring it back around, it comes in at a weird angle. No, I guess maybe it doesn't. Was I hallucinating before? Yeah, here. You can see how trying to bring this around to face the ship forward isn't working. And that's why it's better to rotate around the vector3.up rather than the pilot ring.up. Because you want to be specific to the ship, not to the object. And that way, when you bring it around like this and you rotate it, it comes back around, you can see. Now, the problem with this, of course, is that you're no longer flat. You're kind of arbitrarily veering off of true upwards. There are a couple of ways around this. One of the ways is to have a smoothing function where it continually tries to smooth out. And another way is to keep the heading as a vector 3 and then just apply a look at. I think that we're going to go ahead and just use a smoothing function because it's easier. So down here we're going to say pilot ring.transform.rotation equals quaternion dot look rotation, and then we'll give it our pilot ring dot transform dot forward. Forward, yeah, there it is. There's no transform. There's no need for a pilot ring dot transform. It's already a transform. There we are. And then here we can specify a vector3 dot up. Now what this does is it locks all of our ships into Star Trek coordinates. That is to say, our ships are always going to be locked into a flat plane relative to each other. So you're not going to have ships that come in upside down or anything like that. I think that's fine for now. We can figure out whether or not we like that later on. To be honest, I think it's probably fine. Another thing to note is that we are currently not mouse locked, so we're going to want to do that. So mouse lock. Zaku says, what do you work as, by the way? I program for a green power company, a green energy company. I do a lot of database stuff and communicating between radically different devices. So, you know, it's the same kind of thing you're seeing here, I guess, but dumber. Erdroy says maybe you could calculate point on plane and look at the point. It would be better. I'll post some code in a minute. I'm not sure if it would be better or not, Erdroy. This is pretty straightforward. I mean, it's just 3 lines of code. So what we're going to do here is actually put it in as a quaternion slurp. Pilot ring dot rotation Time.delta time. Just because I like slurps. So now, for example, if we were to bring it over like this, you can see how it steadies itself back down to flat. I like how that feels in comparison to how we were doing it before. It feels pretty easy and natural. Oh, I forgot about locking it. That's right. We were going to lock the system. So it's cursor lock mode. How do I get the cursor lock mode? Let's look it up. Unity cursor lock. Cursor.lock state. Yeah. Down here, we're going to say void on disable. I think there's an on disable. If not, we'll deal with that later. Equals confined. There we go. So that should allow us to switch between locked and confined modes. And that should mean that we no longer have any problems with our mouse wandering off the side. Obviously, that doesn't happen in a construction mode. It only happens in free flight mode. But that shouldn't be too bad. Yeah, that's fine. So of course, now the question is, well, what's our velocity going to be and some stuff like that. What I'm going to do is I'm going to add in a velocity indicator right here on our object. And there's a couple of ways to do that. My favorite way is to make it part of the material itself. So to do that, we're going to want to go into our ship parts again. And then over here, we're going to go ahead and get a flattened casting of this. So if we were going to UV unwrap this as a projected from view bounds, we now have a very nice visual, which we can now paste any kind of texture we'd like into. So over here in materials, we're going to create a new material, which we will call a velocity material. Drop that onto our ring. Boom. And the velocity material can have an albedo, which changes color in some way. We don't have a very good set of colors for this. I guess the knob is actually the one that's the least stupid looking. We'll go with the input field background for now. I'll need to create a better set of options later on. So you can see that as we change the offset and the tiling, we get different results on how it looks. We should. We don't seem to be, though. That's interesting. Seriously, the tiling should be like, oh, that was interesting. So the offset works, but the tiling is broken? Okay, so I don't know what was up with the tiling, but now it works. So as you can see, if we increase the tiling, we get a set of different responses. Now the problem with this is that it is a clamped image rather than a repeating image. That's not necessarily bad. If we bring our tiling down to like 0.1, we can change our offset like this, and you can see how that fills in. We're going to need to have a dedicated image, though. This image is no good. Let's go ahead and open up. I don't actually know where those images are. I guess those are default images. God damn it. I still don't have my computer fully rigged up, so I have a hard time doing some of this stuff. I'll go ahead and open up some Clip Studio Paint and try and get this to work. I know what I can do. I can copy it in from another import new asset. Show and explore. Fine. We can go up to a different project like the Galactic Line and go into our assets and into our textures and find a texture that's more suitable, like the eyebrow texture. Why is the eyebrow texture the only one that's even vaguely suitable? Let's use this one. Boom. There we are, bar. Now the thing is that bar is not what we really want to do. So we're going to go ahead and open that up in our editor here and rotate it 90 degrees. Rotate canvas by 90 degrees counterclockwise. Save. Bar. Come on, there you are. Now we can go into this object and set this as the bar rather than whatever it was set for before, like so. And if we make this a 1, oh, come on. If we make this into a 1, we should be able to see that at some point it... Oh, is this using transparency? Okay, so we have to actually change it over to... no, it's not transparency. It should work. Oh, it's just really, really faint. I see. Let's go ahead and make it less faint. So if we do this, and then 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 we do black and white. That seems more or less correct. Come on. There we are. All right, so Zaku says, my coding skills aren't the best, but the most pleasant thing I've coded was a batch butler, which was like when you call a company, press X key to, and I had a lot of free time, so basically I used all the keys on the keyboard to do one function or another. There are some fun ideas and some fun games built around the idea of having all of the keys on the keyboard do something. And it's definitely kind of a fun approach. It's also really opaque. So here you can see that as we increase our tiling, what we get is this choppier look. So that's basically what we're going to want to do. We're going to change the color of the albedo to something that's noticeably not a ship. So purple is probably best. Maybe like this. And we'll bring the smoothness way down. And what we're going to want to do is have this represent our speed. There are a couple of ways to do it. One way is to do that way that I just showed you, where it chatters, loops. Another method is to use the offset so that it appears to fill up. Now, if we do that, we have to do it the other way. I put it in upside down. So let's flip it. Transform, flip, not horizontal. There's no reason to flip it horizontal. Transform, flip, vertical, and save. Enter, save. There we are. So now, if we put this in at 0, 0, you can see that it's almost full, and we can continue going up to make it completely full, or we can drop it down to make it less full. The key to this is that rather than looping, we're going to want this to be clamped. So if we clamp it, then when we are in here and we are changing these values, we get a very different result. So for example, this is clearly mostly empty and this is mostly full. And as we move on up, you can see that we don't get any more stuff down here. So what's going to be important for us is figuring out the offsets that we want and setting all of that stuff up. So let's create a new script, which we are going to call adaptive material script. And we're going to just drop that onto our pilot ring here. And we'll pop up our adaptive material script. Public float public vector2 minimum offset maximum offset, and minimum tiling, maximum tiling. And down here we will go ahead and put in a public float throttle. It can be anything, but percent, I guess. And then down here we'll put a public float percent get set percent equals value update visual and get return percent. Update visual. So we need to have a material which we are modifying. We're going to take that from our mesh renderer. So require component type of mesh renderer. And then down here we are going to say protected material. And in start we will say mesh renderer mr equals get component mesh renderer. And we'll say material equals mr.material. Now we're not using the shared material because every ship might have different velocities. And even within the same ship, you might have different pilot rigs that have different velocities. If you're doing something complicated like remote piloting or turrets or something. So every one of these has to have its own material. We could probably do something a little bit more efficient than that, but we're not planning to have thousands of these on screen at once, and we can always make it a little bit more optimal later if we have to. So down here, we are going to say that material equals, we're also going to put in an update visual here. Material dot main texture offset equals vector2 dot lerp. And we're going to go ahead and say it's the minimum offset, maximum offset, and percent. And then here, we're going to do the same thing, but for the main texture scale. Except for scaling is backwards from tiling, right? I actually don't know whether this is reversed or not. Well, I guess we'll know pretty soon since it's the value I'm actually using. Right, so that should work. If we take a look at our adaptive material, we're going to want to find the maximum and minimum values that we would like to assign. So these tilings are all going to be 1s, and the minimum and maximum offsets are going to be 0 and 0. This is going to be 0.22, and then this one is going to be negative 0.88. There we go. And now what we need to do is tell the ship to actually reflect onto that with its continuously streamed throttle rating. So to do that, we have a lot of options, but I think the best option for us is to create a throttle public float throttle equals 0, public float throttle get return throttle set throttle equals value. And then down here, we're going to need to have a public float event. Do we have a float event? No, we don't have float events yet. Let's just go ahead and make them. Public, we need to have Unity events here. Public class float event inherits from Unity event for floats. There we go. System serializable. And here we'll have a float event throttle changed. On throttle changed. And here we say on throttle change dot invoke throttle. Perfect, right? The only thing that we want to do here is we may end up wanting to limit it from 0 to 1. So for that, we're going to say if, value equals float.clamp or mathf.clamp 0, 1 value. That'll make it so that it doesn't go above or below 0 or 1. You know, it'll be in that range. So with that in mind, what we're going to do is we are going to go down to our reactor here, and on this throttle changed, we're going to drop in the pilot ring and tell it to change the percent to whatever the current throttle percent is. Now we need to have a way to change the throttle. There are a lot of ways to do the throttle changing. We're going to use 2 in particular. Throttle change. We're going to have a throttle change input axis for people that don't have mouse wheels. But we're also going to have the mouse wheel because that's an easy thing to do. The thing is, I don't know whether I like the mouse wheel to be part of the throttle changing system. I don't know if I want to hard code that because there are a lot of situations where the mouse wheel might be useful for something else. So we'll put it in for the moment, but we may need to change that later. Anyway, we need to go into the project settings, the input settings, and add in a throttle input. So the throttle input, we're going to go ahead and use plus and minus just for now. Later on we'll change it, I'm sure. It can also be changed however you'd like. So what we're going to do, I think, is sorry, I'm trying to figure out the best way to handle this when I use the mouse wheel as well. If you take a look at the mouse scroll wheel here, it's just called mouse scroll wheel, and it uses the 3rd axis. We can do the same thing here with our throttle. We can change this to the 3rd axis. The problem is that the 3rd axis is something that shouldn't be scaled by time, whereas plus and minus do need to be scaled by time. Or no, wait, because plus and minus can just be like one jump. Okay, that's fine then. That's what we'll do. So here what we're going to do is throttle change, float throttle change equals input, or sorry, if input.get axis .get button. So if input.get axis, okay, I'm trying to figure out the best way to do this. Float throttle equals input.get axis throttle. If input.get axis down, get button down, throttle. If throttle is greater than 0, throttle plus equals 0.1f, else throttle minus equals 0.1f. I'm not 100% sure that that's going to work, but let's find out. So we've got this ring, and as we throttle up, it doesn't look like anything is happening. Okay, so hold on. If we take a look here, our throttle is currently set to 0. Okay. And it's still set to 0, no matter what I do. Any error messages? No? That's interesting. So input.get button down, debug.log, throttle changing. So it says throttle changing, but it's not actually changing the throttle. Interesting. I can only assume that means that this is actually 0. So we're going to go ahead and say I'm an idiot. fucking idiot. I was overriding the throttle I was trying to change with a new variable named throttle. Not the smartest guy on the block. So, as I thought, the mouse wheel doesn't actually work. Minus makes it go up and plus makes it go down. That's kind of dumb. But the mouse wheel doesn't work because using the mouse wheel doesn't count as a throttle down or mouse button down situation. Which is really kind of obnoxious. So unfortunately, that makes it difficult for us to use both of these off of the same inputs. These need to be minus and plus rather than plus and minus. The issue here is that this will never count as a mouse button down. Do I need to change this to key or mouse button? Is that okay? It's called mouse movement there. What happens if I change it to a mouse movement type? No, it doesn't. Still doesn't work. Breaks entirely. All right, because it's no longer considered a mouse button. All right, so that's going to be a key or mouse button, and we're going to have to think about what we would like to do here. Basically, if it is a button-based system, we only want to go up once in a while. If it is a mouse wheel-based system, we want to go up every time the mouse wheel is triggered. That's really annoying that we can't just set it up to do it. Protected float throttle input delay equals 0. If throttle input delay is greater than 0, then throttle input delay minus equals time to delta time. Else, if throttle input button, else, boom. If throttle does not equal 0, throttle input does not equal 0, throttle input delay equals 0.2f. 0.25f maybe? We still got a problem where the mouse wheel is not going to be as effective. So you can see how there's something happening here where the throttle actually gets reduced back down to 0. And the reason for that is because this isn't an else if throttle input is less than 0. That's what we needed. So the mouse wheel doesn't appear to be catching. It doesn't appear to be working. So what we're going to do is we're going to just assume that the mouse wheel is part of the deal here for now. All right, so if we go back in here, what we're going to do is we're going to have throttle change by throttle axis. And then up here we're going to have public bool control throttle with mouse wheel equals true. So this here no longer has to have its throttle delay or any of that stuff because we can just grab it and multiply it by our time to delta time times time to delta time. There we go. By mouse wheel. If mouse wheel, then come on, throttle input equals input.getAxis mouse scroll wheel. That was a nice hissy sound. I bet that sounded great. Throttle plus equals throttle input divided by 5. If throttle input does not equal 0, then throttle is there. That doesn't have any delta time attached to it because that should be an absolute Perfect. That might be a little bit slow. My mouse wheel is super, super fast, and it's still a little bit slow. So we'll reduce that down some. There we are, that's better. So the only problem with this is that there is no going backwards. There are a lot of options where we might want to be able to go backwards, or at least tell it to go backwards without actually changing the direction of the ship. And right now that doesn't work. What we can do is, for throttles that are below 0, we can change the direction of our flight. So what we're going to do for that is we are going to put in a couple of extra values here. So we're going to need another event here, which will be a bool event. I don't believe we've got a bool event set up either, so let's set it up. And then down here we will say 10cast1 says I am Sneck. I don't know what that means. Erdroy says you could lerp the value to get a smooth look on the visible throttle value. I'm not too concerned about that since we're multiplying the throttle inputs well enough. It's not a big deal, but I could. You're certainly right there. And I might later on if I decide that I want it to look smoother. Public bool event on reverse. On set reverse. So what we want to do is have a Boolean value, public bool reversed equals 0 or false. Public bool reversed get return reversed set reversed equals value and on set reverse.invoke reversed. This will quickly allow us to set this reverse whenever we need to. What we're going to do is we are going to check and see whether the value is below 0. So if value is greater than 1, value equals 1. But if value is less than 0, then what we're going to want to do is check and see whether or not we are within. Well, a better way of doing that. Better way to do that is value equals mathf dot clamp value negative 0.25f and 1. And then we'll say reversed equals value less than 0. Down here we will say if reversed equals value return, so we don't spam it. Perfect. 10cast1 says he's been on some Facebook meme pages. Sorry, that's one thing I definitely don't know anything about. I never joined up with Facebook, and I'm regretting joining up with Google. But that's fine. I didn't ever think they were going to take off. So what we need for our adaptive material is we either need this or another object that will reverse things. We're going to make it this just for sake of ease of use. To be honest, we probably didn't even need that on reversed Boolean thing if we were able to just the float here should be working. So what we're going to end up doing here is our update visual. We are going to make sure that we do it differently depending on whether we are forwards or backwards. So first we're going to say if % is less than 0 or is greater than 0, then we do these things, but we also want to make sure that our local scale is positive. So if transform.localScale.y is less than 0, transform.localScale equals vector3.1, or it's we're going to need to set the scale, aren't we? Protected vector3 local scale. So here in start, we'll say local scale equals transform.localScale. And I think that it's Y that we want to change, but let's just go ahead and check that since it's pretty easy to check. So this is our piloting ring. And scaling on the Y, it's not Y, it must be Z. Of course it's Z. What am I thinking? Yeah, it's Z. So that's what we'll do. So else, we're going to do this exact same thing, but in the opposite direction. So this is going to be -%, and it's going to be times 4. Actually, there's no reason to make it times 4. We want to make sure the player knows that they're not moving very fast. And if the z is greater than 0, then transform.localScale equals local scale with a -z. So new vector 3, localScale.x, localScale.y, and negative localScale.z. And we didn't end up having to even use the reverse Boolean, but we are going to have a use for it later, so we'll leave it in. All right, so as we increase, you can see that we're moving forward, and as we decrease, you can see that at some point it turns backwards. See? Now the other thing we might want to do is change the color of the material to show that we are moving backwards. If we do this with minus and plus, it's pretty fast, a little too fast. Let's go ahead and make it a little bit slower and change the color of the material. So protected color, default color, and public color, reverse color. So when we're down here, what we're going to do is change the material color. Material.color equals reverse color. And then here we're going to say, oh, that can be done in here actually. Default color. Of course, we have to save that default color. And of course, we have to set up the reverse color. So we'll just grab it and make it orange. There we are, perfect. So now you can see that as we reverse, we get this situation, and as we accelerate, we get this situation. The only problem with it now is that at 0, it apparently decides that it's reversed, which is not something we want. So we're going to just fix that up, which I believe happens here. Yeah, if % is greater than or equal to 0, that's better. Zoom. So then what we need to do is obviously have the ship try to steer so that it is aligned with the ring and moving at the recommended throttle level. That's something that requires a little bit more work, but the reason I wanted to have this happen is because all of these ship components can now draw from the system here to try and figure out which direction they are trying to get the ship to go. That should allow us to have them autonomously try to steer the ship in the correct direction. There are a couple of questions, such as how accurate do I want my thrust physics to be? If you have a thruster that's off to the side, do I want it to end up spinning the ship? Probably not. That level of accuracy is not really very fun. I don't think so anyway. I think that's why the Space Engineers guys ditched it. I mean, they can obviously do it. It's just a Boolean toggle in their engine. But it is annoying to try and build ships that obey that kind of stuff, especially since in real life what you'd do is you'd gimbal the engines, and I don't want to have it so that I'm having all of the weight offset calculations happening and then having all of the gimbal calculations happening and having them always come out to 0. That sounds really dumb. I might later on add in some kind of threshold system where it will eventually start to be annoying, but for now I think we can assume that all of these engines have a very, very good gimbal. The question is for things like these things can be rotated, right? These guys here can rotate. So we want to be able to hook those into the ship's control system. How do we do that? That's the hard part here. What we really need to do is have it make a chain of requests. This engine knows the direction it's facing, and it needs to say, okay, I'm facing, you know, this direction, and then you go up here to the rotor, and the rotor says, oh, okay, well, I've got thrusters facing in this direction, and then you go up here to the piloting station, and the piloting station goes, I'm trying to go this direction. And then the rotor goes, okay, well, let's rotate these guys, and then we will rotate the engine into the correct situation. The reason it's a little complicated is because I need this to work regardless of the direction the engines are facing. So I don't want it to be like the rotor always has its z-axis as the forward axis or anything like that. I want it to be using a solver method to try and figure out which direction it should point in order to align the majority of its thrust-producing elements with the correct vector. That is, of course, assuming that it's set up to help with this thrust vectoring and not for some other system. So as you can see, that can get a little complicated. But when we think it through, it's only complicated for me, the developer. For the player, it's like, yeah, whatever you put on the back of those things, if you're setting it up as a standard rotor, it's just going to automatically try and move those into the right thrusting positions. The only questionable elements here are when the engine counts as on or viable, and that sort of detail work. What we're going to do is we're going to create a new engine element that we can put on our engines. So for that, we're going to go ahead and put in a thruster. And I don't know whether or not I've been using a ship, namespace ship. Yeah, I have. That's fine then. So we'll go ahead and pop this open. Namespace ship. We're going to need to do the exact same thing within our ship control system here. So namespace ship. Should work. See if it barfs. No barfing? No barfing. Hurrah! We got some bounds commentary. We're going to go ahead and comment that out. And the last thing we're going to want to do is set up this thruster so that it understands what the heck it's doing. We're going to have a set of elements for that. We could simply turn the thruster component on or off based on whether or not it's on or off. That's not too bad of an idea, except that there are some things that we might want to do when the thruster is off. For example, we might want to have an animation play that shows the thruster shutting down. Well, that animator shouldn't be too bad because we would have an animator attached to the thruster object and it would handle that nice. So maybe I am a little uncomfortable with the idea of just using the Unity systems for this because I think that we may want to have something update inside of the thruster class even if the thruster object is turned off. We want the thrust system to be turned off, but the game object to still be on. So for that, we're going to put in a new Boolean, public bool on ready. We'll call it ready. And here we say public bool ready get return ready. Set ready. Oh, this should be ready. Ready equals value. If ready equals value, return. Ready equals value, and we'll want to have a new Boolean, public bool event on ready state changed. We say on ready state changed dot invoke ready. There we are. And that will allow us to quickly determine whether the engine is on or off without actually turning the mono behavior on and off. Now we're also going to want to have it be able to tell us its forward vector. So public vector3 thrust vector. And this we're going to go ahead and assume is going to be return transform.forward. It may not be. We may have to fix that, but probably right. We'll find out later. Public float throttle equals 0. And obviously we are going to want to have the same basic setup that we had everywhere else. So that would be get return throttle. We're going to need public float event on throttle changed, set throttle equals value, on throttle changed dot invoke throttle. There we go. Those should allow us to plug anything we would like into the engine when we're building it. But obviously there are going to be some fundamental elements inside of the engine that need to respond to these values as well. Most noticeably these particle systems, which we're firing here. We want these to respond to the engine's thrust, the engine's throttling. The problem is that these don't have any way for us to set this rate over time via a float event. Just to show you what I mean, if we go, oh, we haven't actually put the engine object onto this yet, so let's put it on thruster. There's our thruster, and there's our other thruster. There we are. But if we go down here to this rocket, and we tell it that there is a change to the float values, and we drop the particle system in, we look at the particle system, there's time and there's simulate, but there's no emit. Same with the particle system renderer, you can change some scales, but you can't really tell it to emit something. So because of that, we're going to need some helpers. These helpers are probably easiest to put here on the throttle, so that's what we'll do. Region helpers, end region. Public void emit from particle system. Particle system. System. So these don't, as you can see, these don't take a float value. So we can't use it like this after all. I have to put it on the particle system itself, don't I? All right, we'll create a helper script and put them on the particle systems. So down here in scripts, we're going to create a, oop, that's not what I wanted. Create a new C# script called particle system helper. We can also use the system similar to this to add in new functionality to the particle systems, which I've forgotten how to do. I've even forgotten the name of how to do it. Let's go ahead and try to look it up while I'm here, though. Unity, add in functionality to sealed classes. How to modify is a way to prevent adding to using extension methods. That's what I'm looking for. All right, so extension methods are what we're looking to do. So what we do is we call it a helper class. All right. That works fine. That's not what we want, though. Declaring an extension method. Here we are. Public static class game object extensions. So we're going to go ahead and change this from helper to extensions. I'll just go ahead and delete it. Did I spell that right? I did not. All right, so this is just a class. It doesn't actually have any mono-behaviory to it. And what we do is we public static void emit float particles. It cannot override, that's fine, that's all good. Okay, I think that's actually all I needed to do. Now all we need to do is Wait, how do I put this into... Does it automatically compile because it's called extensions? Or this game... Okay, so here it is. I've missed this part here. This particle system... particle system. Float particles. There we are. So here we can say particle system, or this dot emit. I can't do it, can I? Particle system dot emit. It's been so long since I've tried to do this. Mathf dot seal particles. So emit is actually already emit number. Emit particles. There we are. But I actually don't know whether or not this is going to work because it's been so long since I've tried to do this. Extension methods must be defined in a non-generic static class. Oh, my bad. Best overloaded match for emit has some invalid arguments. Of course, because that's not it. It's a... Yeah, emit int count. What do you mean it has some invalid arguments? Oh, seal to int. My bad. Clear. All right, so that should work, at least in theory. I don't know why you can't call emit directly. I guess it has to be an int rather than a float. I might have just wasted a lot of time because I probably could have just made it an int. I'm super brilliant. So what we're going to do is we're going to tell it to grab these and emit from them. So here's emit int, but there's no emit. I don't think that worked. Okay, I don't care. We're going to go ahead and just make it an int. So to make it an int, we are just going to go back into the thruster here and add in an int event. So we might as well put the int event in the same place as these others. This is not their permanent resting place, but whatever. And then no. Int event on throttle frame. That's what we'll do. We'll have two of them here. So here in the on throttle frame, we're going to go ahead and say if throttle is greater than 0 and oh, well, we can actually do that here with these readinesses here. If not ready and throttle is not equal to 0, throttle equals 0. That'll do. And then down here we will say if not ready, then return. Later on we may throw an error. Sure, we'll go ahead and throw an error. Public Unity event. Not ready error. So here we'll say not ready error dot invoke. Perfect. All right, so here in update, we're going to go ahead and keep all of our throttle counters. And what we'll do is we will say throttle counter plus equals throttle times time.delta time times 10. And then we will say if throttle counter is greater than 1, then we want to emit. So on throttle frame mathf dot floor to int throttle counter. And we're also going to go ahead and say throttle counter minus equals math.floor to int throttle counter. And that should end up, oh, it has to be throttle thing.invoke, that's fine. And that should end up working. We should be able to do it like this. We better be able to do it like this, because I've wasted a lot of time doing nothing. Particle system. Emit. Alright, so that one does work. So we'll just drop these in and tell them to emit. Up here in this other rocket, we'll do the exact same thing. Nope, that's an armor plate. Not going to be able to emit very many particles from an armor plate. All right. So the other thing we need to do is actually turn the default emission off for these particle systems. Right, there we go. Peter Nerlich says, hi. Hello, Peter Nerlich. So we don't currently have any throttle set up for this, but what we're going to do is we're going to allow those engines to be wired up to any sort of inputs and outputs that the ship I/O systems can have. Now the problem is, how do you do that wiring? That's something I'm not sure I know the answer to. Best answer anyway. Basically, we want these engines to respond to the throttle of this ship, but how do we wire them up to take that throttle? Well, the answer might simply be using reflection, but that's pretty aggressive. Fundamentally, we have a couple of issues. One of those issues is that our mono behaviors are going to have a hard time having their Unity events correctly mapped. For now, however, let's just continue to use Unity events. We're going to have to solve this in the long run, but here on this on-throttle changed, we can simply add in the two rockets and set their throttle equal to our throttle. That shouldn't be too hard. Only problem, of course, being that our throttle can go negative. So you can see that particles have started coming out. So these particle systems are intended to look relatively decent, but they're not intended to be shut off or shut on. And you can see that they look a little bit stupid when I turn them on and off. You can pre-bake them, but the problem is you can't really do it in the way I would like. So what we're going to do is we're going to give them a much lower lifetime and a much higher starting speed. 0.5, 0.3, 0.5, 0.3, and we'll make that into 5 and 3. I don't know how much that'll help, though. Peter Nerlich says, this looks cool already. You have a very low bar for what is cool, but thanks. So here you can see that we are emitting just little poofs. They're not really lasting long enough for us to make any impression. Go ahead and punch this up to 0.5. We may have to radically increase the number of particles involved or turn on particle trails. Both of those should be fine. Let's go ahead and turn on trails for our particles. And we'll probably want to turn these up to 10 and turn these up to 8. The trails don't currently have a texture assigned to them, or renderer rather, so what we're going to want to do is just assign this same default particle default particle. And that should have assigned it to all of them, I think. Yeah, good. It's not really looking as good as I'd like it to look. Can I get these to... I could use some skewing, but that would look really weird. Let's go ahead and set their lifetime to 1 and see whether that helps. The real problem here is that I need to have a faked particle event, something that looks like it's actually particles but isn't. And that's what I had before, but it looks bad when you need to turn it on and turn it off. So we'll have to figure that out later. For now, I guess this is okay. What we can do is we can radically upgrade the amount of particles we're using here in the thruster. Go ahead and say public float particles per throttle per second, and we will make that 100. And then down here, we'll multiply this by particles per throttle per second. Peter Niller says, well, the concept of indicating acceleration. Yep, yeah, this is okay, so back when I was first doing prototypes for the Galactic Line, like last year, I came up with this system. This system is really fantastic if you don't want the player's controls to vary based on frame rate or ship qualities. So, for example, if I move the mouse up, I know that I'm going to always go the right amount up, because it's disconnected from the actual performance of the ship. So in Space Engineers, you know, if you build a big slow ship, you're like trying to get it to move. But with this, you don't have to worry about that. It just works. It was such a good control system, especially given the secondary things that you can do with it, that I felt really annoyed that I couldn't put it into the Galactic Line, because the Galactic Line has no systems controls like that. You don't need to have detailed controls, but it's okay. I have a method now that I can use it now, and that's gonna work out pretty well. So the secondary considerations, in case you're wondering, WSAD in this particular configuration will attempt to strafe your ship right, left, up, down, instead of controlling your motion along the axis. This allows you to do things like dodge and land and do all sorts of other stuff relatively easily. Q&E will probably spin you, but I'm not sure how much spinning there's really going to be. Either way, there's a couple small little details we have to fix. One of which is that if the throttle is less than 0, we don't do this. If throttle is greater than 0, then do this shit. If it's less than 0, don't, because otherwise we build up a massive particle debt. Zoom. So you can see that now these engines just sort of automatically go whenever our ship attempts to go. This is something we're going to have to change a little bit later when we finish our wiring system, because I don't know how our wiring system is really going to work in the long run. I have to think of a really good way to do it. But what we can do now is get our hinges working. So these hinges, what they're going to do is they're going to have a couple of different modes. And what we're going to have is, I don't know whether I want it to be in the hinge or as a secondary plugin, but for now I think we can put it here in the rotor itself, and we can move it around later if we need to. So what we're going to want to do is move these hinges to the proper offsets so that our engines are pointed in the correct direction. And to do that, we need to get all of the vectors and then find our target vector and do a little bit of math. Charles Hayes says, what shortcuts do you use to enter and exit play mode? Control P and Control Shift P. That's all I use. I think it's Control P and Control Shift P. Yeah. So Control P plays and stops, Control Shift P pauses and unpauses. Region, thruster, stuff, and region. Note, may want to move all of this to a plugin. Public, vector 3 thrust vector. Get thrust vector. Oh gosh. So what we're going to do is we're just going to find all of our thrusters that are in existence and then walk through them. We want to have some thruster max thrusts. public float max thrust equals 100. That way we'll be able to weight this particular thought. Yeah, Charles, those are the default keys. I think you can change them if you want to, but they're the defaults. Thrusters equals get components in children thruster. We may want to bake this permanently later on because this is a little bit expensive. Thrusters. If thrusters equals null or thrusters, what do you want to say? Length equals 0. Thrusters equals that. Right, good. So, true. Why is this marked as an error? Oh. This shouldn't be an error. Should be fine. Oh, I'm not returning a value. Of course. So here is what we're going to want to do about the thrust vector here. Return thrust vector. There we go. This equals vector3.0. And what we're going to want to do here is just go through all the thrusters. For each thruster, I can't spell thruster. Thruster T in thrusters. Thrust vector, go ahead and put in a float here. Float thrust equals 0. So we'll say thrust plus equals t dot thrust. We're also going to want to say if t dot ready, if not ready, then continue. Otherwise, thrust plus equals max thrust, and then we will say thrust vector equals vector3 dot lerp thrust vector comma t dot forward. T dot thrust vector, thrust vector, yeah, T dot thrust vector, and then we will just say T dot max thrust divided by thrust, and that'll give us a vector3 that is correctly oriented based on the weighting of these thrusters, and then that's a pretty easy way to do it. I recommend that you remember that if you ever have to have this sort of system where it's a little bit difficult to figure out how heavy the various weights are. You can just do this. But that means that we end up with a thrust vector that should be just right. What we need to do, however, is calculate out how to align our rotors so that our thrust vector is along the proper thrust. And that is a little bit more difficult. To the point where I have to think about it for a while. I'm not 100% sure how to do it. Well, let's get started. Public void align thrusters to vector. Align thrusters to vector. And we're going to have to pass it a ship control system. I guess we'll, for now, go ahead and put in a ship control system, debug ship control system. Later on, we'll have some kind of actual wiring setup, but that's fine for now. If system equals null, then system equals debug ship control system. So what we want to do is get our engines aligned with the quaternion of the pilot ring. So we want them to face the same way as the pilot ring. Now, we could actually do this in a really, really dumb, funny way. We might as well do that now, just for the sake of making sure everything is connected up properly. So what we're going to do is, here in our thrusters, we're going to say t.transform.lookat, and then we will take the system.pilotring.forward. And that is a very goofy way to do this. And it may also end up, I think it's actually going to end up pointing them the wrong direction, but it should work. What we're going to want to do is have this get run every frame. Align thrusters to vector. That'll do. Perfect. No barfing. Hurrah! So as you can see, it's all aired up because we forgot to set it. As I said, you got to remember to set this shit. There we are. That's the piloting ring. Oh, did I break it? I broke our graph here. I should really make this mass graph calculate automatically whenever it enters into gameplay. So in start, calculate mass graph. Alright, so there's still a lot of barfing going on here. Oh, I never set thrusters, sorry. Okay, so you can see how the thrusters are doing their own thing now. It doesn't look like they are even vaguely correctly oriented. I'm not getting the expected changes in direction. In theory, they should change rather radically. In practice, they're barely moving at all, which is really odd. What if we were just say t.transform.rotation equals pilot ring.rotation? Well, that's definitely more like what I had in mind. You can see how the offset is pretty bad. It's 90 degrees wrong, and of course, it's not what we want, because what we have here is the engines doing a dance, and what we really want to have happen is we want our rotors to be doing that dance. In order to figure out what sort of configuration we want our rotors to be in, we have two basic options. One is we can use inverse kinematics, and another is that we can try and calculate it out. The way that you do inverse kinematics is you figure out which direction the thrusters would be facing if you turned the throttle, if you turned the rotor a little bit. And that will allow you to detect whether turning the rotor up or down will be better for your overall alignment. In order to do that, we need to be able to determine how the rotor vectors would change if we were to rotate slightly. So for that, let's go ahead and create a function here, public float, our public vector3 engine alignment, our transform vector with offset. Vector3 vector float offset. And the way you do this is you create a quaternion and then you rotate the quaternion around the axis that you need to rotate. And what we're going to do is we're going to make our quaternion equal to the transform of our vector head here, of our rotor head, which I think we actually are. I think this is on the rotor head. So that does do a rotation as a world space. Good. And then what we can do is, and I don't think this will change the way that the rotors transform works. I think this is a clone. These are structs, not classes. So what we can do is we can go into the quaternion and set up our transform rotation to be slightly different. Axis rotation. There are some things that we need to be able to do here. Well, we could actually use some of these, like set from to rotation, which creates vectors from and towards. That might be pretty nice. There are ways to make the quaternions do what we need them to do, I think. I might be mistaking them and thinking that they are something else, like a matrix 4x4 or something. But we should be able to use this set from to rotation, right? So if we make our quaternion into a set from to rotation of the current vector and the vector we would like, we might be able to get the offset, right? I don't think that's going to work. Oh, here it is. These are what I was looking for. They're just static quaternion values. So basically, we're allowed to specify a variety of angles here, and then try and figure out what we need to do in order to get them to be in the right direction. So for that, we can use this angle axis to figure out what sort of change we're going to have. Well, when we rotate these guys, they only rotate on a single axis. And that axis is axis, as defined. See? So we'll just take that axis, and that's a local axis. So we'll take an angle of 1 or of offset, and our axis of axis. We have a number of things that we need to consider. One of which is, should this axis be in world coordinates or local coordinates? Well, we'll try it with local, and then we'll try it with world, and we'll find out. Because we're talking about an order of operations thing, and I'm not sure which way it goes. So then what we're going to do is we're going to take our vector, and we're going to transform it through that. So return q dot wait, can I not transform a rotational? Why can't I remember how to do this? I know how to do it. I just need the quaternion to rotate a vector. Am I blanking on this just out of sheer dumbness? Is there something that is a quaternion but has different functionality attached? I know I could use a matrix 4x4 out of this. So I could create a matrix to do this, but that seems like it's stupid. Well, whatever. So with this M4, I can multiply out a point and get a value. I can multiply a vector or multiply a point, and I think it's the vector I need to do. But I'm not 100% sure that this is correct. In fact, I'm not even 50% sure that this is correct. So let's go ahead and test it. And the way we're going to test it is here in align thrusters to vectors. Once we have the thrusters, we're going to actually just grab the vector. So vector 3 thrust vector equals, and then we grab get thrust vector, like so. Now what we're going to do is we are going to find the offset for this vector. So vector 3 off 0 equals transform vector with offset thrust vector, and then the offset would be -1. And then we do the same thing here with 1. And then what we'll do is we'll determine which of these is closer to actually being correct. So vector3 target vector equals system.pilotring.forward times -1, because we want to fire backwards, not forwards. We're not going to want to be in reverse. So what we're wanting to do here is set up our offsets so that that all gets detected. So float p0 equals vector3 dot dot off 0 and target vector. Float p1 equals vector3 dot dot off 1 and target vector. And based on whichever of those is higher, that's the direction we go. If p0 is greater than p1, then we want to set our speed. So we'll just set our current velocity. Current velocity equals, what's the max velocity here? Max speed. Else, there we are. So in theory, that will work. Shall we find out what sort of incredibly wrong, stupid shit I did because I wasn't thinking about matrices correctly? Okay, so you can see that we're getting some vibration here. But it's definitely not doing what I want it to do. Well, it seems to be snapping between 180 and 0. It might be that this has to be in world coordinates. Probably. Either that or the vectors have to be in local coordinates. Which would actually make more sense, wouldn't it? To make the vectors in local coordinates. Let's go ahead and do that. So this is going to be in transform dot inverse transform vector, or direction. Here it is. There we are. And then this one will be the same. There we go. Well, they are exactly 90 degrees off in opposite directions. So that's actually closer than I expected, but I don't know why they would have different different directions. 90 degrees is something I can understand because I have a feeling these engines, their up is not what I think it is. Yeah, you can see how this, if we take a look at the local values here, this green is not, I don't know what that is. I doubt it's the right direction. I don't know whether that's up. Yeah, that must be up. Okay. So what we have to do is we have to have these engines return up. Later on, we'll have to figure out what we actually want them to do in the long run. But when we try and get our thrust, it's going to be up. That also explains why they were negative. No, it doesn't. Okay. Oh, okay. That actually works. It's exactly backwards, but that is 100% fine because that's super easy to fix. So over here in our rotors, we just stop inverting our pilot ring, because apparently it's already inverted. All right, so you can see how the rotors now track the pilot ring to try and keep us going. That's kind of the point. There are a couple of things left for us to do, though. We're going to want to have some smoothing here. So we're going to have a, rather than current velocity, we're also going to have a protected float target velocity equals 0 and protected bool I guess we'll just use busy for that. Target velocity. Spell something right for once. Okay, so here we're going to go ahead and set this to our busy equals true. And then we're going to want to set our target velocity target velocity. 1 is probably not right. How about max velocity times time.delta time? That should probably be a little bit better. Or we could just set it to max speed again. Yeah, that's, you know what? It's probably fine as max speed now that I'm thinking about it. Yeah, that's all good. So what we're going to want to do is up here, well, we're going to want to multiply it by, or divide it by our vector, aren't we? So the dot vector should be between -1 and 1. So if we were to add it in, we could just say time, or divided by p0 plus 2. And here we can say divided by p1 plus 2. And that will allow it to go slower as it approaches our target. But up here in our update, we're going to need to have our target velocity and our current velocity getting set. So current velocity, if target velocity does not equal 0, then current velocity equals mathf.lerp, current velocity, target velocity, and time.delta time times responsiveness. We could also just say lerp to velocity. I've already programmed that stuff in, you idiot. So lerp to velocity, target velocity. Woo, woo. Okay, so that smoothing isn't as smooth as it could be. And I think I might have the... No, that should be correct in terms of them going slower as they are more aligned. Maybe what I want to do is multiply them by 1 minus... if that's a negative, it's not going to work out, though. Multiply them by... float target throttle. Well, you know what? Rather than minus... Well, yeah. So float target throttle equals mathf.max p0 p1 plus 1. And that'll give us a value between 0 and 2. So target throttle minus equals, or equals 2 minus target throttle. And then here we can divide it by target throttle, or multiply it by target throttle. And that should get extremely close to 0 as things happen. So what we're going to want to do is also have that work in a slightly different way a little bit later on. When we get to 0, we want it to stop. So here you can see that they come up to the vector that they need, and then they nicely slow down into a controlled stance. Now you notice that the ship doesn't turn. It's just the engines that end up wobbling in and out onto the control vector. We can do a whole bunch of things with this. We can lock it in place. We can have it snap down nicely. But I kind of like the organic wobble that this gets, like it's micro-adjusting after having over-adjusted a little bit, which is precisely what it's doing. So we'll leave it like this for now, and later on we'll add in some extra values to make this work in a slightly different way. So I'm going to take some screenshots and then call this a day. If anybody has any questions, now is the time to ask, because I'm going to stop real soon here. Created a reverse IK control system that handles arbitrary engine setups. And we'll just do a couple of examples here, like control print screen, or alt print screen. And now what we'll do is we will grab one of these engines here and rotate it. I think that's actually kind of nice. And let's go ahead and put that back the way it was. And then let's just show a quick little sample of a reverse vector. IndieDev. Perfect. All right. We also need to delete stuff from YouTube. All right, well, have a good day, everybody. And maybe I'll see you all again on Sunday. Same time, same bat channel.